In this section, we're going to lay some groundwork for right triangle trigonometry. This is our 11.2 and we're on page 100 of your workbook. We use capital letters to name the vertices or the corners of the triangle. We use lowercase letters to label the sides. The letters that are across from each other match. We'll look more carefully at this in a minute. The side across from the right angle is called the hypotenuse. We've talked about that before, but it's going to become even more important as we continue. Angles and sides that are across from each other that don't touch are called opposite. And a side that touches one of the non-right angles that is not the hypotenuse is called adjacent. And we'll look more carefully at that in a minute too. So we can see in this first example, the corners are labeled with capital letters already for us, and we need to label the sides. So here's how that works. Across from this capital C, we call lowercase side c. Across from the capital A, we have lowercase a. And across from the capital B, we have small b. Okay, so you always go across from the letter to make the letter match. The corners are capitaled, the sides are small. So which side is the hypotenuse? The hypotenuse has to be across from the right angle, so that's here, angle A. Next question says, what's opposite to B? So here's capital B. Across from it is little case b. Then the next one says, what's opposite to C? So here's C. Across from it is little c. So then the next question says, what's adjacent to B? So here's B. Adjacent means next to, but not the hypotenuse. So if A is the hypotenuse, that stays. That doesn't change because it's across from the right angle. Adjacent, the other side that's next to it, would be C. If we look at C, the hypotenuse is A, that's next to it, but adjacent means it's not the hypotenuse, but it's next to it. So the next to it would be, adjacent would be B. Let's do one more example. We'll label the sides first. So here's capital X, so across from that would be little x. Here's capital Y, so across from it would be little y. And here's capital Z, so across from it would be little z. It's a good idea to write the hypotenuse on there directly. So here's our right angle. So let's just label this one right away as our x. So then, opposite to y would be little y. Opposite to z, straight across from it, would be little z. Adjacent to y, so again, adjacent means next to, but not the hypotenuse. We've already got the hypotenuse labeled, so adjacent would be z. And adjacent to z, so it can't be the hypotenuse, would have to be y. So trigonometric functions or ratios are only used on right triangles. There are 6, but we'll only work with the main 3. So trig functions always have to have an angle after it. So we say the sine of the angle is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent of an angle is equal to opposite over adjacent. We can remember this by so, ka, toa. And if you look right above, this is sine is opposite over hypotenuse. Ka is cosine is adjacent over hypotenuse. And toa is tangent is opposite over adjacent. The trig function must tell you what angle we're looking at. And that's right after the trig function. So here this says find the trig functions to 3 significant digits. So here it says find the sine of 36 degrees. So we find the angle that's 36 degrees. The sine is opposite over hypotenuse. So opposite it would be 52.9. And the hypotenuse, here's my right angle, so the hypotenuse will stay 90. So you take 52.9 divided by 90, and you get 0.58777, and it keeps going. 3 significant digits would be here, 3 numbers. This tells us to go up, so our final answer would be 0.58. Let's look at the cosine. The cosine of 36 degrees, so we're still using this angle. The cosine, remember, is adjacent over hypotenuse. So adjacent means not the hypotenuse, but the other one that's next to it. So we'd have 72.8 over the hypotenuse, which is 90. So if I take 72.8 and I divide by 90, I get 0.808888. 3 significant digits would be right here. This 8 tells us to go up. So we would get 0.809. And the tangent of 36 degrees, we're still looking at 36 degrees here. Tangent, remember, is opposite over adjacent. So the opposite would be 52.9, and adjacent can't be the hypotenuse, it's the other side, 72.8. If I do that division, I get 0.726648. 3 significant digits would be here. The 6 tells us to go up, so we get 0.727. In this problem, it tells us to use A for our angle, so here's my A. So across from that would be the opposite. Here's my right angle, so across from it would be the hypotenuse. And that means that the side that's left is adjacent. So remember that sine is opposite over hypotenuse. So that would be 47.5 over 62. So if I do that division, I get 0.766 for 3 significant digits. After that, 6 is a 1, so that 6 will stay the same. Cosine, remember, is adjacent over hypotenuse. So adjacent is 39.9, hypotenuse is 62. Do that division, and I get 6.64, and then the next number is a 3, but there's a 5 after it, so the 3 would round to a 4. And then finally, tangent is opposite over adjacent. So opposite it is 47.5 over adjacent is 39.9. And that's 1.19047. 3 significant digits is the 1.19. The next number is a 0, so the 9 stays a 9. So we'll have 1.19 for our tangent.